High above the quiet clouds of Saturn, a delicate ribbon of ice drifts silently through the dark. It stretches outward for hundreds of thousands of kilometers, thinner than you might ever imagine, yet wider than the distance between Earth and the Moon. Countless frozen fragments, some no larger than grains of sugar, others the size of mountains, move together in a slow, weightless waltz around their golden giant. Tonight, we will drift out to Saturn and learn how these frozen halos came to be and what they quietly whisper about the nature of time itself. Welcome to Let's Learn While You Sleep. Tonight, we journey nearly 1.5 billion kilometers from the warmth of our sun to a pale golden world wrapped in the most breathtaking ornament in our solar system. Saturn, the sixth planet from the sun, is a gas giant so light that, if you could find an ocean large enough, it would float. And around its equator, spinning in silence, lies a system of rings so thin that if you shrank it to the size of a football field, it would be thinner than a single sheet of paper. Over the coming hours, we will explore how these rings formed, what they are made of, how they move, and why scientists believe they may not last forever. You do not need to remember any of it. Let the facts drift by, like the ice particles themselves, and let your breathing slow as we settle into the quiet orbit of a distant, beautiful world. To understand Saturn's rings, we must first understand Saturn itself. It is the second largest planet in our solar system, roughly 9.5 times the diameter of Earth, and it is composed almost entirely of hydrogen and helium, the two lightest elements in the universe. Unlike the rocky worlds closer to the Sun, Saturn has no true surface. If you were to descend into its golden clouds, you would find only deeper and thicker atmosphere, until the hydrogen itself was crushed, by immense pressure, into a strange metallic liquid. At its core, scientists believe there may lie a small, dense region of rock and ice, perhaps 15 to 20 times the mass of Earth, though this remains uncertain. Recent measurements from the Cassini spacecraft suggest the core is not a solid sphere, but something softer, what researchers describe as a diffuse or fuzzy core, blending gradually into the metallic hydrogen above it. Saturn spins remarkably fast. A day there lasts only about 10.5 hours, and this swift rotation flattens the planet visibly at its poles, giving it a gently squashed appearance when viewed from afar. A year on Saturn, however, is very long. It takes approximately 29.5 Earth years for Saturn to complete a single orbit around the Sun. And yet, despite its immense size and its quick spin, Saturn is astonishingly light. Its average density is less than that of water. It is the only planet in our solar system for which this is true. A gentle giant made of little more than gas, gravity, and time. High in its atmosphere, pale clouds of ammonia ice drift in bands pushed by winds that can exceed 1,700 kilometers per hour, among the fastest winds ever measured on any world. And floating above all of this, suspended in silent orbit, are the rings, tethered to the planet by the quiet, invisible hand of gravity, turning endlessly in the cold. Rings themselves are not a single solid band, though from a great distance they may appear that way. They are, instead, a vast congregation of individual objects, each one following its own orbit, each one bound to Saturn by gravity, yet held in a delicate cooperation with its countless neighbors. Scientists estimate the rings contain many trillions of particles, ranging in size from microscopic dust grains to chunks of ice larger than a house. And although the rings are enormously wide, spanning roughly 280,000 kilometers across, they are also extraordinarily thin. In most places, the main ring system is only about 10 meters thick, the height of a 3-story building, suspended across a distance wider than many planets. If you were to stand on one of the larger ring particles and look along the plane of the rings, you would see a dazzling, shimmering landscape of ice, extending far beyond the horizon, each particle tumbling, glinting, colliding gently with its neighbors in slow motion. Approximately 95 to 99% of the ring material is water ice, remarkably pure, which is why the rings reflect sunlight so brightly. The rest is made up of small amounts of rocky material, silicates, and traces of organic compounds that give certain rings their faint reddish or tan tints. The rings are labeled in the order of their discovery, with letters of the alphabet, not in their spatial order from the planet outward. So we have the D ring closest to Saturn, then the C ring, the B ring, the Cassini division, the A ring, the F ring, the G ring, and finally, far out in the cold, the enormous and tenuous E ring. Each has its own character, its own density, its own story. And as we drift among them tonight, we will find that each ring is shaped by forces subtle enough to escape casual notice, yet patient enough to sculpt entire worlds from nothing more than falling snow. Where did these rings come from? This is one of the oldest questions in planetary science. And even now, after decades of study, the answer remains beautifully uncertain. For much of the 20th century, scientists assumed the rings were ancient, perhaps as old as Saturn itself, formed alongside the planet some 4.5 billion years ago, in the early turbulence of our solar system's birth. But evidence gathered more recently, particularly from the Cassini mission, which orbited Saturn from 2004 to 2017, has challenged that view. The rings, it seems, may be remarkably young. Current analysis of the ring material suggests they could be only about 100 million to 400 million years old, a mere eye blink compared to Saturn itself. This means the rings may have formed long after the dinosaurs first walked on Earth. What might have produced them? One leading hypothesis is that a moon of Saturn, an icy body, perhaps the size of Mimas or smaller, wandered too close to the planet and was torn apart by tidal forces. There exists, around every massive body, an invisible boundary called the Roche limit. Within this limit, the gravitational pull of the planet on the near side of a moon becomes stronger than the moon's own gravity can resist. The moon, quite literally, is pulled apart. Its fragments then spread into orbit, flattening over time into a disk, sorting themselves by size and composition, until, after many millions of years, they become the rings we see today. Another possibility is that a passing comet, or perhaps two colliding moons, provided the raw material. We may never know exactly which event occurred. What we do know is that the rings are clean, bright, and remarkably icy, qualities that suggest they have not been accumulating space dust for billions of years. They are, in a sense, a recent gift to a very old planet, an ornament whose origin we are only just beginning to understand. To imagine the rings properly, we must think about how the particles within them actually move. Every chunk of ice in the ring system, whether the size of a grain of salt or the size of a cathedral, is a tiny moon in its own right. Each follows a nearly circular orbit around Saturn, obeying the same gravitational laws that govern Earth's motion around the Sun. The closer a particle is to Saturn, the faster it must travel to avoid falling inward. Particles near the inner edge of the main rings complete a full orbit in less than 6 hours. Particles at the outer edge may take 14 hours or more. This difference in orbital speed means that neighboring particles are always, ever so slowly, sliding past one another. They bump, they graze, they exchange tiny amounts of energy, and these countless, gentle collisions are what keep the rings astonishingly flat. Over long stretches of time, collisions smooth the orbits, damp out vertical motion, and press the entire ring system into that paper-thin disk we observe today. Within this flat plane, however, the rings are anything but uniform. Close-up images from the Cassini spacecraft revealed waves rippling through the rings, spiral patterns traced by the gravity of distant moons, and strange, sharp-edged gaps carved clean by tiny shepherd moons hidden within the system. One such moon, Pan, orbits inside a gap in the A ring called the Decay gap and has a curious walnut-like shape, with a prominent ridge around its equator built up from ring material it has gently swept aside. Another moon, Daphnis, orbits in a nearby gap and raises delicate waves along the ring edges as it passes, waves so precise they look almost choreographed. And so the rings are not still. They are alive with motion, a slow, unending dance of ice and gravity, stretched across distances the mind can scarcely hold, turning endlessly in the night. Let us now drift closer and consider the scale of the rings as a whole. The main ring system, stretching from the inner edge of the D ring outward to the faint boundary of the A ring, spans roughly 282,000 kilometers in total width. That is nearly 3/4 of the distance from the Earth to the Moon, laid out in a thin, luminous disk. And yet, despite this enormous lateral reach, the vertical thickness of the main rings is astonishingly slight. In most regions, the rings are thought to be only about 10 to 30 meters thick, which is to say, about the height of a small building. Imagine a sheet of tissue paper stretched across the length of a football field, and you begin to sense the proportions involved. Were you to view the rings precisely edge-on from a great distance, they would nearly vanish, becoming little more than a thin silver line drawn across the blackness of space. Astronomers have observed this phenomenon during what are called ring plane crossings, moments when Earth, in its own slow orbit, passes through the flat plane of Saturn's rings. During these crossings, which occur roughly every 15 years, the rings briefly fade from view in smaller telescopes. Galileo himself, observing in 1612, was bewildered when the strange lobes he had seen beside Saturn simply disappeared. He did not understand what he was seeing. The resolution of his telescope was not fine enough to reveal the rings as a disk, and the idea of a vast flat halo surrounding a planet was still unimaginable. It would take nearly half a century before Christian Huygens, observing with a better instrument in 1655, proposed that Saturn was encircled by a thin, flat ring, detached from the planet itself. That idea at the time seemed almost heretical in its strangeness. Nothing in the known cosmos resembled it. And yet there it was, hanging in the sky, quietly waiting to be understood. In this way, our comprehension of Saturn's rings has itself unfolded slowly, across centuries of patient looking, each generation inheriting a slightly clearer picture than the one before. Within the broad expanse of the rings, astronomers have identified distinct divisions, gaps, and subtle structures, each with its own name and character. The brightest and most prominent rings are labelled, somewhat prosaically, in the order of their discovery rather than their position. Moving outward from the planet, we pass first through the faint D ring, then the broad and luminous C ring, then the dense and brilliant B ring, which is the most massive and reflective of all. Beyond the B ring lies a dark band known as the Cassini division, a gap nearly 4,800 kilometers wide, named after the Italian-born astronomer Giovanni Domenico Cassini, who first observed it in 1675. Past the Cassini division lies the A ring, which is itself cut by a narrower gap called the Encke gap, discovered by Johann Encke in the 19th century. Further out still, beyond the main rings, lie the much fainter F, G, and E rings, diffuse and ghostly, composed of finer particles and tenuous clouds of dust. The F ring, discovered by the Pioneer 11 spacecraft in 1979, is particularly strange. It is narrow, braided, twisted, and shepherded on either side by two tiny moons named Prometheus and Pandora, whose gravitational influence keeps its particles from drifting away. These shepherd moons, small and irregularly shaped, weave along the edges of the ring like quiet guardians, their gravity nudging stray particles back into formation. The E ring, the outermost and most diffuse, is thought to be continuously replenished by tiny ice grains erupting from geysers on the surface of the moon Enceladus. Somewhere in that silent darkness, Enceladus is venting water vapor and ice through fractures at its south pole, feeding a ring that spans hundreds of thousands of kilometers. And so the rings, far from being a static ornament, are an active, evolving system, shaped and reshaped by moons, gravity, collisions, and the slow breath of icy worlds. Each division and gap is a fingerprint of forces at work, a record of resonance and motion written into the geometry of the disk. To read them is to read the history of Saturn itself. Consider now the composition of the ring particles themselves. The overwhelming majority, perhaps more than 95% by mass, is water ice. Not a dirty, dust-laden ice, but a remarkably pure, crystalline water ice, which is part of why the rings shine so brightly. Water ice is an excellent reflector of sunlight, especially when it exists in fresh, clean form, and the particles of Saturn's rings reflect back a substantial fraction of the light that falls upon them. Exactly why the rings remain so pure, after potentially millions or even billions of years of exposure to micrometeoroid dust and cosmic debris, is still a matter of active research. One leading hypothesis holds that the rings are relatively young, perhaps only 100 million to a few 100 million years old, which would mean they formed long after the planet itself and have not had time to accumulate significant contamination. Evidence from NASA's Cassini mission which ended in 2017 after nearly 13 years of orbital study, offered support for this younger age, based on measurements of how much interplanetary dust the rings have absorbed and how quickly ring material appears to be raining down into Saturn's atmosphere. According to Cassini data, the rings may be losing mass at a rate that suggests they could fade entirely within the next few 100 million years, though this estimate carries significant uncertainty. If true, we live in a rare epoch, a brief cosmic window during which Saturn's rings exist in their full splendor, and our human moment of observation is, in the grand scheme of planetary time, extraordinarily fortunate. Other researchers, however, argue that the rings may be far older, possibly dating back to the formation of Saturn itself, roughly 4.5 billion years ago, and that certain mechanisms might keep them appearing young and clean. The debate continues, carried on in quiet papers and careful measurements, in conference rooms and observatories, across the patient community of planetary science. There is no rush. The rings, whatever their true age, will hang in the sky long after our questions have been asked and answered, turning slowly, faithfully, through the centuries yet to come. Let us turn now to the delicate choreography of gravity that sculpts the rings into their intricate forms. The structure we see is not random. It is shaped, moment by moment, by the gravitational pull of Saturn's many moons, which tug and nudge the ring particles into resonant patterns. A gravitational resonance occurs when the orbital period of a ring particle forms a simple numerical ratio with the orbital period of a moon. For example, the inner edge of the Cassini division corresponds to a location where particles would orbit Saturn exactly twice for every single orbit of the moon Mimas. At this 2-to-1 resonance, Mimas tugs the particles repeatedly in the same direction, amplifying their motion, destabilizing their orbits, and eventually clearing them away. In this manner, a moon hundreds of thousands of kilometers distant can carve a visible gap in the rings, as surely as a sculptor shapes stone. Other moons create different effects. Some, like Prometheus and Pandora, act as shepherds, confining ring material into narrow bands. Others embedded directly within the rings, such as Pan and Daphnis, sweep out empty lanes as they orbit, creating the Encke and Keeler gaps. Daphnis is particularly enchanting. As it travels through the Keeler gap, its small gravity raises delicate vertical waves along the edges of the surrounding ring material. Waves that rise and fall like ripples on a pond, casting long shadows across the rings during Saturn's equinox. These waves, photographed by Cassini, have been measured at heights of several hundred meters, remarkable structures rising from a ring otherwise only meters thick. And beyond these, there are density waves, spiral patterns that propagate outward through the rings, like the grooves of an enormous cosmic record, each wave a signature of a distant moon's pull. To study the rings is to study the geometry of gravity itself, written in ice and light across the vacuum of space. Every gap, every ripple, every faint striation carries information about mass, motion, and time. And in the silence of the outer solar system, these patterns continue to unfold, slowly, endlessly, indifferent to whether anyone is watching. Among the most captivating gravitational sculptors within the ring system are the small moons known as shepherd moons, whose quiet work shapes the edges of ring structures with astonishing precision. Two of these tiny worlds, named Prometheus and Pandora, orbit on either side of the narrow F-ring, a thin thread of icy debris that winds around Saturn like a strand of spun glass. Prometheus, the inner shepherd, races slightly faster than the ring particles, while Pandora, the outer shepherd, moves slightly slower, and through their combined gravitational pull, they confine the wayward particles into that delicate braided filament. Without these guardians, the F-ring would spread outward and dissipate over time, its particles scattering into the dark space between larger ring zones. Consider, for a moment, the scale of this dance. Prometheus is only about 86 kilometers across at its longest dimension, a tumbling potato-shaped fragment of ice and rock, and yet its gravitational whisper is enough to pluck streamers of material from the F-ring each time it passes close. Photographs from the Cassini spacecraft revealed these streamers as faint, finger-like channels drawn across the ring, ghostly evidence of an invisible conversation between moon and particle. Pandora performs the opposite role, nudging errant particles back inward, so that together these two small worlds sustain a structure that might otherwise vanish into the void. Elsewhere in the rings, other moons carve gaps, form wakes, and create scalloped edges that the Cassini mission captured in exquisite detail. The moon Daphnis, only about 8 kilometers across, orbits within the Keeler Gap in the outer A-ring, and as it travels, it raises vertical waves of ring material, waves that rise and fall like frozen tides, their crests catching the distant sunlight. These tiny moons, some no larger than a mountain on Earth, shape structures thousands of kilometers wide, a reminder that in the silent mathematics of gravity, even the smallest bodies may leave enduring marks, their subtle pull echoing across the vast crystalline sea that encircles the pale golden face of Saturn itself. Let us drift now toward a question that has puzzled astronomers for generations, a question as elegant as it is unresolved. How old are Saturn's rings, and how long will they endure? For much of the 20th century, many scientists assumed the rings were ancient, perhaps as old as Saturn itself, formed alongside the planet roughly 4.5 billion years ago, when the solar system was young. Yet the data returned by the Cassini spacecraft in its final years, particularly from the daring series of orbits known as the Grand Finale, has shifted this picture considerably. During those final passes in 2017, Cassini flew between Saturn and the innermost edge of the rings, measuring their gravitational pull with unprecedented precision. From these measurements, scientists estimated the total mass of the rings to be surprisingly small, roughly 40% the mass of Saturn's moon Mimas, a small icy world only about 400 kilometers across. This low mass, combined with the remarkable cleanliness of the ring ice, has led many researchers to propose that the rings may be astonishingly young, perhaps only 100 million to 400 million years old, which in cosmic terms is the blink of an eye. If this younger age is correct, then when dinosaurs roamed the Earth, Saturn may have worn no rings at all, or perhaps rings very different from the ones we see today. The leading hypothesis suggests that the rings formed from the destruction of an icy moon or comet that wandered too close to Saturn and was torn apart by tidal forces, its shattered body spreading into the flat disk we now observe. Yet this remains an active area of research, and some scientists continue to argue for older origins, pointing to uncertainties in how quickly ring material darkens over time. And there is another melancholy possibility woven into the data. The rings may also be slowly vanishing, as charged particles drawn inward by Saturn's magnetic field rain gently down into the planet's upper atmosphere, a soft, luminous decay called ring rain, quietly falling. The phenomenon known as ring rain is itself a gentle wonder, one that connects the rings to the planet in a quiet, continuous exchange of matter. High above Saturn's cloud tops, ultraviolet radiation from the distant sun and collisions with tiny meteoroids occasionally ionize water molecules within the ring particles. Once electrically charged, these particles are no longer bound purely by gravity, for they become sensitive to Saturn's immense magnetic field, which threads through the rings like an invisible net. Guided by the curving lines of that magnetic field, the charged water molecules slide inward along vast arcs, traveling tens of thousands of kilometers before settling softly into Saturn's upper atmosphere, where they dissolve into the hydrogen and helium clouds. Measurements from the Cassini spacecraft, together with earlier observations from the Voyager missions in the early 1980s, suggest that this rain is falling at a considerable rate. Estimates vary, but some analyses indicate that the rings may be losing material fast enough to disappear in as little as 100 million to 300 million years, though other estimates are more conservative and extend the lifetime further. Either way, the rings are not eternal. They are a passing feature, a fleeting ornament in the long biography of the solar system. And we are fortunate to live in the narrow window of cosmic history during which they can be seen. Imagine, if you will, a future Saturn, its golden globe unadorned, its magnificent halos gone, leaving only perhaps a thin, faint band of dust and the memory of something once glorious. And imagine, too, a past Saturn before the rings formed, a planet perhaps as bare as Jupiter, waiting across long millennia for a small moon or wandering comet to meet its fate, and transform the planet's appearance forever. In this way, the rings are not merely a structure, but a moment, a slow breath drawn and released across geologic time, and the quiet luminous particles falling gently into Saturn's atmosphere tonight are the soft exhalation of that breath, dissolving into the planet's ancient, endlessly swirling clouds. Consider now the perspective of the Cassini spacecraft itself, that remarkable robotic traveler which taught us nearly everything we presently understand about the rings. Launched in October of 1997, Cassini journeyed for almost 7 years across the vast darkness between worlds, before arriving at Saturn in July of 2004, and it would then orbit the planet for 13 years, returning hundreds of thousands of images and an ocean of scientific data. It was Cassini that revealed the vertical structures within the rings, towers of ice rising up to 2.5 kilometers above the otherwise paper-thin ring plane, casting long shadows across the surrounding particles during Saturn's equinox. It was Cassini that watched Daphnis raise its waves, that traced the streamers drawn by Prometheus, that measured the mass of the rings during its final daring dives. And it was Cassini that on the 15th of September in 2017 ended its mission by plunging intentionally into Saturn's atmosphere, transmitting data until the very moment it burned away, becoming itself a small addition to the planet it had studied so faithfully. The decision to end the mission this way was made to protect the possibly habitable moons Enceladus and Titan from any risk of contamination, and so the spacecraft gave itself to Saturn in an act of scientific care. Consider the images it sent back in those last hours. The rings spread beneath it, the cloud bands of Saturn rising to meet it, the final photographs transmitted as it fell. All of our present knowledge of the ring particles' composition, their temperatures, their delicate structures, their slow decay, descends from the patient work of this single machine and the thousands of scientists and engineers who guided its journey. Somewhere in Saturn's clouds tonight, the atoms that once formed Cassini are drifting, mingling with the ring rain, dissolved into the vast pale atmosphere of the world it came so far to see, a quiet ending to a long and luminous voyage across the silent dark between the planets. Cassini's final chapter, which scientists came to call the grand finale, began in April of 2017, and it was perhaps the most daring maneuver ever attempted in the exploration of the outer solar system. The spacecraft, running low on fuel after nearly 13 years in orbit, was directed to perform 22 dives through the narrow gap between Saturn's innermost ring and the planet's cloud tops, a region roughly 2,000 kilometers wide, a region no probe had ever entered. Consider for a moment the silence and the stakes of that passage. On one side, the swirling ammonia clouds of a gas giant, stretching downward into pressures that would crush any machine. On the other, the delicate outer edge of the D-ring, sparse with icy particles that could, at orbital speeds, puncture the spacecraft's thin shell. And yet, Cassini threaded that needle again and again, sending back measurements of Saturn's magnetic field, its gravitational structure, and the mass of the rings themselves. It was from these final orbits that scientists derived one of the most important numbers in modern planetary science: the total mass of Saturn's rings, estimated to be roughly 15 quintillion kilograms, or about 40% the mass of Saturn's moon, Mimas. This is a surprisingly small figure, and it hints, some researchers propose, that the rings may be relatively young, perhaps only 100 million to 400 million years old, though this estimate remains the subject of ongoing debate. On the 15th of September in that same year, Cassini was intentionally guided into Saturn's atmosphere, burning up like a small metal meteor, chosen to end there so that its remains could never contaminate the potentially habitable moons Enceladus or Titan. In those last moments, it transmitted data until the signal was lost, some 83 minutes after Cassini had ceased to exist, because that is how long its final whisper took to cross the void to Earth. A small machine, a great silence, and a legacy of knowledge that will guide our understanding of the rings for generations still to come. Let us turn now, in the softest of transitions, to the moons that shepherd these rings. For Saturn's rings are not simply passive clouds of ice drifting freely through space. They are, in many places, carefully sculpted by small worlds whose gravity combs and shapes the particles into patterns of remarkable precision. Consider Pan, a tiny moon roughly 28 kilometers across, which orbits within a gap in the A-ring known as the Encke gap. Pan has a most unusual shape, resembling a flattened dumpling or a walnut, with a distinct ridge of accumulated ring material running around its equator, as though the moon has been slowly gathering snow as it passes through the debris of its orbit. Nearby orbits another little shepherd named Daphnis, only about 8 kilometers across, which travels within the narrow Keeler gap, and as it moves, it creates rippling waves in the ring edges on either side, tiny waves that rise and fall like the wake of a ship on a frozen sea. These waves can stretch upward from the ring plane by as much as 1.5 kilometers, making them briefly visible when the sunlight strikes Saturn's rings at just the right angle, casting long shadows across the otherwise paper-thin surface. And then there are Prometheus and Pandora, the shepherds of the F-ring, 2 small moons that orbit just inside and just outside this narrow band of ice, their gravity tugging at the particles and keeping them confined in a delicate braided stream. Prometheus, in particular, has been observed stealing small amounts of material from the F-ring during each close approach, drawing out streamers of ice that drift behind it like wisps of fog. In these intricate interactions, we see a kind of slow cosmic choreography, unfolding across millions of years, a dance between ice and gravity and time itself, performed silently in the dark around a distant planet. A dance we have only recently been able to witness, and one that continues, patient and unhurried, whether or not anyone is watching. For now, let the image of Saturn settle softly in your mind. A pale golden world, wrapped in frozen halos, turning slowly in the quiet dark. Trillions of ice particles, each one catching a distant glimmer of sunlight, each one following its own patient orbit, together forming something so vast and so delicate that it almost seems impossible. And yet there it is, and has been, for millions of years before you were born, and will be for millions of years after. There is nothing you need to do tonight, nothing you need to hold on to. Let the numbers drift, let the names fade, let the gentle motion of ice and gravity carry your thoughts outward, past the clouds of Saturn, past the last tenuous whisper of the E-ring, into the deep, forgiving silence of space. Your breathing is slowing, your body is settling, and somewhere above the quiet clouds of a distant golden world, the rings are still turning, patient and beautiful, whether you are watching or not. If you would like to drift further into the quiet wonders of our universe, let your finger find the subscribe button before you fall asleep, and we will meet again tomorrow, somewhere new. Thank you for spending your night with Let's Learn While You Sleep. Subscribe and come back tomorrow night. We'll be here. Sleep well.